I am discuss about the topic self-reciprocal under Fourier transform. Self-reciprocal means if a transformation of a function f of x is equal to small f of x, then the function f of x is called self-reciprocal. Find a Fourier transform of e power minus a square x square. Hence prove that e power minus x square is self-reciprocal with Fourier transform with respect to e power minus x square. Solution. First of all, the Fourier transform of f of x is capital F of small f of x equal to capital F of x equal to 1 by root 2 pi minus infinity plus infinity f of x in e power isx dx. F of x is e power minus a square x square plus isx dx. Here the value of here a is equal to small ax, b is equal to is by 2. Du is equal to ax, du is equal to a into dx. Dx equal to du by a. Then u2 minus infinity to 2 plus infinity. Then capital F of small e power minus a square x square is 1 by a into root 2 e power minus x by 2 by a square x square. The reduction part is e power minus x square by 2 is reciprocal. Put a is equal to 1 by root 2 in equation number 1. The value is e power minus x square by 2. Therefore, e power minus x square by 2 is self-reciprocal. Then one more problem. Find the Fourier transform of e power x square by 2 or show that e power minus x square by 2 is self-reciprocal with respect to Fourier transform. Here this problem 2ab equal to isx, a is equal to small ax, b is equal to is into 2a. Then substitute capital F of x equal to 1 by root 2, 1 by 2 pi into minus infinity plus infinity f of x in e power isx dx. Then here u is equal to a minus I, ax minus ix, du is equal to a into dx, dx equal to 1 by u into du. The limit is minus infinity to plus infinity. Then capital F of e power minus ax into is equal to 1 by a into root 2 e power minus x square by 2 x into ax. Reduction part is e power minus x square by 2 is self-reciprocal. Put a is equal to 1 by root 2 in equation number 1. Its answer is e power minus x square by 2. Then another one problem, find the Fourier sine transform of e power minus a square x square. Find the Fourier transform. Here f of x is e power minus a square x square. Then fc as small f of x, that is root of 2 pi 0 to infinity f of x in cos sx dx. That is fc as small f of x is real part of 1 by 2 into root of 2 by pi 0 to infinity e power minus a square x square into e power isx dx. Let u is equal to ax minus is by pi. Then capital F of e power minus a square x square is 1 by a into root 2 e power minus a square by x square. Okay. The reduction part is the answer. Then another one problem is solved for f of x. The integral function integral f of x sin x dx equal to 1 0 1 0 less than s less than infinity 0 s is greater than or equal to 2. Then solution. First of all, the formula Fourier transform. Then finding the inverse Fourier transform small f of x. Then substitute the values, we get the answer. Then another one important one problem. Find the Fourier cosine and sine transform of x power n minus 1. Then show that 1 by root x is self-reciprocal under that the Fourier sine and cosine transform. First of all, the given value 0 to infinity e power minus x power n minus 1. Then the formula is gamma power n by x power n. Put a is equal to infinity. Then substitute the value fc as small f of x. Then fs as small f of x. Reduction part. Then the finding the given answer. Therefore, x in 1 by root x is self-reciprocal under the Fourier cosine and sine transform. Thank you.